We have this bounded region here, and this time we want to revolve this bounded region around the line, the vertical line, x equal to -1, and then find the solid of revolution. So this is the graph for f of x equal to x, 6x minus x squared, and this is the graph for g of x equal to 0. So this is the bounded region. And the axis of revolution is the line x equal to -1. So we want to take this bounded region and revolve it about this line. And we'll use the shell method. So to use the shell method, again, we'll fill this up with rectangles. Since the axis of revolution is vertical and we're using the shell method, we'll fill this up. We fill the bounded region with the vertical rectangles. And again, we'll take each rectangle and revolve it around the axis of revolution, and we'll get shells, and then find the volumes of all the shells, and then add them together, and that will give us the volume of the solid of revolution. And for this rectangle right here, the corresponding shell would look like this. So this shell would correspond to this rectangle. And then we have the other shells also. So as mentioned earlier, we would find the volume of each shell and then add them all together, and that will give us the volume of the solid of revolution. So first, to figure out what the volume of each shell is, we need to figure out the average radius and also the height of each shell. And for this particular example, again, this rectangle right here, the center of the shell, or the center of this rectangle, the distance from the y-axis to the center of the shell is x, and then the distance from here to here is 1. But our radius is going to be from the axis of revolution to the center of the shell. And so it will be x minus -1. Or we can think of it as the distance from here to here is 1. The distance from here to here is x. So it will be 1 plus x, or the same thing as x minus 1. And we get x plus 1. And that will be the average radius. And then the height of this cylinder, it would be just this graph minus the bottom graph. This graph is 6x minus x squared. The bottom graph is y equal to 0, so we'll end up with 6x minus x squared. And so average radius for this is x plus 1. Height of cylinder is 6x minus x squared. And then our bounded region ranges, x ranges from 0 to 6. For the bounded region, x ranges from 0 to 6. And so our limits of integration will go from 0 to 6. So limits of integration are here be from 0 to 6. The average radius is x plus 1. The height is 6x minus x squared, and then thickness dx. Multiply this out, we'll get 6x squared minus x to the third plus 6x minus x squared. This will be 6x. 6x squared minus 1x squared is plus 5x squared, and then minus x to the third. Antiderivative for x is x squared over 2, Antiderivative of x squared is x to the third divided by 3. Antiderivative of x to the third is x to the fourth divided by 4. 6 divided by 2 is 3, and this is 5/3, and minus 1/4 x to the fourth. And we'll evaluate from 0 to 6. So first, plugged in the 6, so we have a 6 here, a 6 here, and then 6 here. And then plugged in 0, we'll get 0 everywhere here. And then all of this will come out to be 288 pi. So the volume of the solid of revolution is 288 times pi.